Hi, my name is Ashley Porter, and I am one of the math instructors at Blue Tent Online. And I am going to make this video to walk you through a little bit of what a typical class will look like. So I currently teach honors geometry and honors precalculus for the 2019-2020 school year, and I absolutely love it. So next year will be year 2 teaching at Blue Tent, and I'm going to be offering geometry, precalculus, both a regular and an honors option, as well as AP statistics, which I'm super excited for. So if you have a love for statistics and kind of some crazy math, then join AP statistics with me. We're going to have a blast. So what I'm going to do is walk through just what a typical class might look like. So our guided notes, what a typical problem session day might look like for students. Sometimes we play games, especially right before a test, so it's test review, and just some different things that you will see within the classroom, especially if you're taking the classes live. You'll see some live components built into every week. So let's walk through just a couple of different scenarios and what you might see in a typical week. So this is an example of a set of guided notes. This one in particular is from geometry, section 7.3. So we're talking about special right triangles. And I have guided notes provided for students for every section of every chapter that we're going to cover. And these notes lay out specific definitions or theorems or concepts clearly in these kind of big boxes that you see. And you might see 2 or 3 of them in a row, depending on if we're talking about different theorems, different ideas. And then you will always see some examples below. So let me walk through this section just to show you typically in class what we would do. So section 7.3 is about special right triangles in geometry. And we say that the triangle with the angles 45, 45, 90. We call that one of our 2 special right triangles. So typically in lecture, we start with filling out the theorem, filling it out in words, adding a picture. We're going to fill it out in symbols, and then we're going to move down to doing some examples. So in a 45 degree, 90 triangle, so that's one of our special right triangles, the legs, so the 2 legs of the triangle, in this case, we're going to call with a subscript L or a cursive L. The legs are equal. Okay, so our 2 angles are equal. That means the 2 sides opposite of those angles are equal. So let's go ahead and label our legs. Our legs in this case are going to be these 2 sides. And we're going to label those N. So this is a variable N, meaning both those legs are the same length. So the legs are of equal length, and the hypotenuse, which is our longest side, there's a relationship between the legs and the hypotenuse, and that is that the hypotenuse is square root of 2 times the length of a leg. So over here, if our length of a leg is n, that means our hypotenuse length is n square root of 2. So that kind of gives us a quick way to determine a missing side length if we have a 45, 45, 90 triangle. Okay, so in symbols, we kind of already filled in our picture, but in a 45, 45, 90 triangle, then L, which are our legs, are going to be equal to n, and our hypotenuse is going to be equal to n square roots of 2. So if we're given our hypotenuse, we can work backwards and find the length of our legs. If we're given our legs, we can work forwards and find the length of the hypotenuse. Okay, let's do an example. So find the hypotenuse length in a 45, 45, 90 triangle. So I want you to find x, so that's the hypotenuse. Whenever I give students questions like these, I ask them to go ahead and label all of your sides. So we have a leg here, and then we have our hypotenuse, which is always the longest side of our right triangle. Okay, we know in a 45, 45, 90 triangle that our 2 leg lengths have to be the same. So if our leg 1 is equal to 9, leg 2 is also equal to 9, the length. And then we need to find the hypotenuse. Well, from above, I told you that the leg lengths, L, are equal to n. Well, both of our legs are equal to 9. So in this case, n equals 9. And then I told you the relationship is that the hypotenuse is equal to n square root of 2. Well, I'm simply going to substitute in my 9 for my n, so my hypotenuse is going to equal 9 square roots of 2. Now, you could use the Pythagorean theorem on this to figure out the length of the hypotenuse, which is what we did in the previous section. That would take you a little bit longer, a couple more steps, but this is just a quicker way to find the hypotenuse without having to use the Pythagorean theorem. So our hypotenuse length is 9 square roots of 2. Okay, let me do B. So B, we're given the length of our legs. So here's a leg and here's a leg. We're missing our hypotenuse again. So I'm going to go ahead and label leg equals, remember we call our leg length n. Well, in this case, each leg length is 6 square roots of 2. Okay, so we're missing our hypotenuse length. Our hypotenuse is the relationship n square roots of 2. Okay, so here, be careful. We're going to plug in this entire value for n to find our hypotenuse length. So that's going to give us 6 square root of 2 times the square root of 2. And we can simplify this. So we know that the square root of 2 times the square root of 2 is just the square root of 4. Well, then we have 6 times the square root of 4. We know the square root of 4 is 2. So that gives us 6 times 2. So the length of our hypotenuse in our second triangle would be 12. So this is an example of one page of a guided notes. We would talk about a theorem, we would do a couple of examples, and then typically I would leave the last example for students to do on their own, and they would either shout out the answers or tell me the answers in the chat. So we use our chat a lot for students to input their answers. Okay, so now what I want to do is show a typical problem session day where students are working on some sort of problem set of material that they've learned during the week. So this is a section 7.2 through 7.3 practice. So this is a problem set of questions that students would be given on a problem session day. And I typically put students in groups of 2s and 3s, depending on how many show up to the live session. So I like for students to work in smaller groups, and I try to put them with a different student each time we do something interactive so that they are working with different students, different classmates, and helping each other out and just getting to know each other as well. So students will be put in individual groups on Zoom, and I have the ability to pop into each group at any point in time. So I typically pop into students' groups as they're working. They can ask me questions. They can alert me if they need to ask me a question immediately and I'm not in their group. And I've found that students really work well together in groups of 2s and 3s because they collaborate, they make sure they're getting the same answer. If one student is not understanding, then one of them will work it out, tell them how they got what they got. They really work together well, which is awesome. I love it when I see students kind of collaborating and figuring it out amongst themselves before they come to me. So while students are working in their groups, I typically am popping into different groups to see if they need help. Now, if students are working and they're pretty self-sufficient and they don't need me in that moment, then what I do is I come into the main session and I record myself working out the problems myself. So students might be working in groups at this time, and I come and I record how to work out some of the problems so that way students who may have missed the live session can still see them worked out, or if students want to go back and review and see me working them out, they will. Now, I don't work out all of them just for time's sake, but I do work out the ones that I can. So for example, students right now would be working in their groups, and I would come in and I would work out, let's say, number 5. So number 5 says find x in both triangles below. Well, we have a right triangle, we have the 2 legs, we're missing the hypotenuse, so we need to find the hypotenuse, meaning we need to use the Pythagorean theorem. So we need to use a squared plus b squared equals c squared. where A and B are our two legs. So we know our leg lengths are 12 and 5. So we're going to input 5 squared plus 12 squared. And we're missing the hypotenuse. So in this case, it's an x. So we could call this x squared if we wanted. Okay, so now we're just going to use some algebra and solve for x. So 5 squared gives us 25. 12 squared gives us 144. We set that equal to x squared. Let's simplify that one more step. 169 is equal to x squared. So in order to find x, we would take the square root. So x equals the square root of 169. So x equals 13. Okay, so we've used the Pythagorean theorem on our right triangle to find the missing hypotenuse. Let's work out problem number 2 within number 5. Here, we're still going to use the Pythagorean theorem. This time we have one leg and we have the hypotenuse. So we're going to be trying to find A. In this case, it's labeled x. So let's label this as x squared. We have one of our legs, which is 15. And we have our hypotenuse, which is 17. Okay, so now we're going to use algebra again to solve for x. It's a little bit different than the problem before it. So this is going to leave us with x squared plus. So 15 squared is 225. 17 squared is 289. So that leaves us with x squared equals 289 minus 225 is 64. So we take the square root of both sides and x would equal 8. So at any point in time, students might alert me and say, hey, I need help in my group on a specific problem. So I would stop and I would go help them. I would come back to working out more problems. It really depends on the students and how much they need me during that class period, but I'm always popping in and out of the groups to make sure that they are doing all right as well. So that would be a typical week. We would have a lecture day where we're getting through the notes, we're learning the theorems, we're practicing some problems together, and then students would have a problem session day where it's really student-led, and they work through the problems, and then they alert me if they need me, and I pop in. Sometimes the problem session day is taken up with some material that we're still needing to learn, or we need to review, etc. But those are the two main kind of class sessions that you'll see.